Hi, this is Austin with Radical STEM Tutoring, and today we're going to learn how to graph inequalities. Let's get started. So, sometimes in your math classes you might be asked to graph an inequality that looks like this, with two variables instead of one. So these work a little different than our standard one variable inequalities, like maybe x is greater than 5. You would find 0 on your number line, find 5, show that it's not included, and shade in everything above 5. But here we have two variables, so how do we make that work? Well, this is basically going to graph a line onto our xy plane that's going to split it into two pieces somehow. Then everything on one side of the line will be shaded in, because points on that side of the line will make this inequality true. So, our first step should be to solve this for mx plus b form, the equation of a line. Even though we have an inequality symbol here instead of an equal sign, it's still going to work. It will still give us a line. So why don't we try to get y all by itself, and then we'll have mx plus b on the right side. So first, we want to get rid of this 3x that's next to the y. So this is a plus 3x, so to get rid of it, we'll subtract 3x. And if we do it to one side, we have to do it to the other side. So then we get minus y is less than or equal to, I'm going to write the minus 3x here, and a positive 4. Now, we need to make this y positive, so why don't we multiply both sides of the equation by negative 1. So negative times a negative will give us a positive, so we'll have positive y. Now remember, when you multiply or divide an inequality by a negative, that flips your inequality sign. So this is going to become greater than or equal to, now negative 1 times minus 3x, negative times a negative gives us a positive 3x, and negative 1 times positive 4 gives us negative 4. So this is the equation of a line that we're going to graph. So we start, when x equals 0, we start at minus 4, and the slope is 3, so x will go up 3 and then over 1, up 3 and over 1, and same in the other direction, down 3 and over 1. So we could go ahead and connect these to make a line, but we need to ask ourselves, is the line included in our inequality? If it's included, we'll make a solid line. If it's not included, we'll make a dotted line. Well, this or equals, the line underneath tells us that it is included. Y can equal points on this line, so we'll fill it in with a solid line. And now, which side of the plane do we fill in? Well, this says that y is greater than or equal to 3x minus 4, which means y can equal everything on here or everything greater than this line. So we'll shade in the top part of our xy plane. So that is what this inequality is telling us. We started with 3x minus y is less than or equal to 4, and what that means is any set of xy points above this line or on this line make this inequality true, and we can actually check this. If we want to check whether this inequality is true, we can choose any point from this part of the xy plane, plug in those x and y values, and see if this inequality is true. So why don't we pick a really easy point like 0, 0 right at the origin. So we'll check 0, 0. Now if we plug these in, we would have 3 times 0 for x minus 0 for y. Well, 3 times 0 is 0, and 0 minus 0 is 0. So that's just going to equal 0. And sure enough, 0 is less than or equal to 4, which means we shaded the right part of the line. Okay, let's try another one to make sure we know how to do this. So we have a totally different inequality this time, but we can do the same process. We'll solve for y to get our mx plus b form of a line, and then we'll take it to our xy plane and try to graph it. So, to get y by itself, first we need to get rid of this positive x, so we'll subtract x on both sides to get 5y is less than negative x plus 10. Now, to get this y away from the times 5, the opposite of multiplying by 5 is dividing by 5. So we'll divide both sides of the equation by 5 to get that y is less than negative 1/5 of x, and 10 divided by 5 is 2. So now that it's an mx plus b, we see that it's going to start at 2 when x equals 0, and then because this is a negative slope, it's going to point down this direction instead of up. Now it's going to go down 1 and then over by 5, and in the other direction we would go back 5 and up 1. Now, should we make this a solid or a dotted line, this is only strictly less than. It's not possibly equal to. So we need to connect these with a dotted line to show that we are not allowed to use points on the line. And finally, which side of the plane do we shade in? We see that y is less than everything on this line, so we'll shade in the bottom half of the plane. And just like last time, we can check this to make sure that we did it right. Let's pick a point on the shaded in portion of the plane to see if it makes this inequality true. And we'll pick the easy point again, at the origin, 0, 0. So if we plug in 0, 0, x would equal 0, plus 5 times 0, and of course 0 plus 0 is just 0, and that is certainly less than 10, which means we did this one right too. Okay, let's go for one more. So, this one is already solved for mx plus b form, so we don't actually have to do any extra work to start to graph this. Now, since there's no y-intercept, that means that when x equals 0, we're going to start at the origin, and the slope is positive 1/2, so we would go up 1 and over 2, up 1 and over 2, then in the other direction we would go down 1 and back 2, down 1 and back 2. This is a strictly greater than, so we're not allowed to use any points on this line. That means we should use a dotted line to connect these points. And finally, which side of the plane do we shade in? Well, it says it's greater than, so we're going to shade in everything above this line. But this time we can't check it using our same point of 0, 0, because that is on the line that we're not allowed to touch. So we're going to have to choose a different point. But we can still choose something similar that should be pretty easy. Let's check the point 0, 1. So, if x equals 0, then 1/2 times 0 equals 0. And we can clearly see that 1 is greater than 0, which means we did this one right too. Alright, if you found this video helpful, please be sure to like it and share it, and have a radical day.